We all do it every day. We don't actively think about it, and still many aspects of it remain a mystery. I'm talking about speech. When we speak, our speech organs such as the tongue, jaw, lips, vocal cords, and many more collaborate in an intricate manner and specific combination to form, well, words. The study of speech as a motor function is called articulatory phonetics. Researchers in this field are interested in finding out more on how we acquire articulation, both how we develop it and how we use it, what is needed for articulating clearly, but also what went wrong when articulation becomes unintelligible. Now you know about articulation. There's only one little problem. When we speak, we constantly open and close our mouths. However, to study articulation, researchers need to be able to record the movements of the articulators, but how can they do that when the mouth is closed half of the time? Enter electromagnetic articulography. An electromagnetic field generated by a transmitter coil can be picked up as an alternating signal by a receiver coil. If both coils are parallel to each other, the strength of the received signal is inversely proportional to the cube of the distance between the transmitter and receiver. This means the signal gets stronger as the receiver moves closer and weaker as it moves farther away, allowing the distance to be calculated. Additionally, because the magnetic field has a direction, phase shifts in the received signal correlate with positional deviations of the receiver along the field's central axis. But since the magnetic field strength depends only on distance and extends in all directions, knowing the distance alone does not determine the receiver's exact position. For this, we need to introduce a second coil, transmitting at a different frequency. The receiver now picks up a composite signal, which can later be decomposed into its individual components. The alternating signal induced in the receiver varies in both magnitude and phase, depending on the receiver's position within the intersecting magnetic fields emitted by the two transmitters. By analyzing these variations, it becomes possible to calculate the receiver coil's coordinates and thereby determine its precise position in space. Now, there's just one more challenge. If the receiver coil tilts, the signal strength decreases proportionally to the cosine of the tilt angle, and as a result, the calculated distance from the transmitters appears greater than it is. To correct for this, a third transmitter coil, operating at a different frequency, provides an additional reference signal. This allows the receiver to determine the tilt angle and compensate for its effect, which ensures an accurate position measurement. The explanation you just heard was mostly taken from a paper by Schönle et al., which was written in 1987. So if you'd like to dive deeper into the details of the measuring principle of electromagnetic articulography, you will find a link to the paper in the description below. Recent EMMAs have both more transmitter and receiver coils, but the principle remains the same. To record speech with an EMMA, a person is seated below the transmitter holder. Measurement sensors containing the receiver coils are placed at specific positions on the articulators of the participant. Reference sensors are placed at positions on the head that do not move during speech to control for head movements. The EMMA takes a sample of all sensor signals with a frequency of 1250 Hz, meaning for every second of data transfer, 1,250 locational samples are generated. For some experiments, this resolution is too high and thus often downsampled to 250 Hz. But for now, this is how researchers measure the movements of the articulators, giving us fascinating insights into how we speak. And I've talked for long enough. I'd love to hear your voice. What did you like about this video? What can we improve? Let us know in the comments or send us an email. All the rest you can find on our website. Thank you so much for tuning in, and I hope you have a great day.